Hello and welcome. My name is Trismegistus. In today's video, we're going to read through Friday Facts 374 Smarter Robots. Hello, today we are going to talk about some flying robot behaviour improvements. Some of the problems we fixed were reported countless times, so I hope that some people will appreciate it. Quality of life versus flashy features. I know that some of you are mainly looking forward to the new content, and that just quality of life improvements aren't the kind of thing that make people buy the game and get excited for. But I strongly believe that if you want to add content, mechanics and systems to a game, which already isn't simple, there is always a risk of it just being too much. By doing quality of life improvements, we reduce the small hassles and annoyances, which effectively create an extra mental space to enjoy more in the game. It's like cleaning your room before getting a new toy. So, to make things clear, the reason that we make and present these kinds of changes is not because we don't want to make new flashy features, we just want the new stuff to be enjoyable without a burden of having too much to deal with. But don't worry, we will show something new next week. So this one is basically a kind of an improvement over the existing behaviour. They do talk about it in some depth, so I won't go into it. Explaining it, because I say they do a pretty good job of explaining what the problems are. But yeah, it's basically like a quality of life one. It's quite interesting that they decided to do this first. There is also a hint, I think, about a change to the game that's coming. It could be a reference to a mod though, so not sure about that, but there's a sort of a hint that there's of something that we might be getting in the expansion. Smarter robot tasks by Oxid. Logistic and construction robots have been in the game for a while, and at their core, they are fairly simple entities. A logistics robot, for example, may be told to go pick up an item from a chest and deliver it to another chest. So far, so good, but in Factorio, there usually is more than one item to be transferred, so what does the game do when tasked with transferring, say, 500 items from one box to another? Just to skip ahead to the diagram, that's basically what's going on here. So we've got a passive provider chest and a requester chest, and it's just a demonstration. So you've got bots coming in, transferring red belts from the passive provider to the requester chest. The old way. In Factorio 1.1, the game keeps a list of all idle robots, including those hiding away in Roboports. And when a task needs to be taken care of, it selects the nearest idle robot from that list. So, to transfer 500 items from a provider chest to a requester chest, the game would find the first idle robot closest to the provider chest and task it with the transfer. This robot now has a task, so it is removed from the list of idle robots. But we still have 499 other items to transfer, ignoring robot capacity bonus for simplicity. The logistic network simply repeats the previous steps for all of the other items, find the next closest idle robot, task it with transferring the next item, and so on until there is a robot for each 500 items in the box. So if you know anything about code, that's an array presumably, or a list feature. And basically it's just a list of all idle robots, and it has got location in it, so it is a bit smarter, but basically it just says, right, this job needs to be happening here. Where's the nearest idle robot? Assign it to the list, and then it goes through that list of idle robots, assigning enough idle robots to do all of those tasks. The problem with this strategy is that while the first few robots may be located in robots reasonably close to the provider chest, by the time we get to the last items, the network may have to reach for robots at the other end of the factory because there is no closer idle robot for the task. The end result is that the first batch of robots will arrive at the chest, take the item and deliver it to destination, and then recharge and go have a nap in a Roboport. Lazy robots. Transferring a single item was all these robots were tasked with, and the remaining items have already been assigned to other robots. After that, a slow trickle of robots from faraway parts of the factory, will come in and transfer the remaining items. And it's exactly what's being shown here. And if you've ever played the game, particularly with large numbers of bots, large number of items, etc., you'll have seen this behaviour where the first bots dash in and do the first half of the job, and then they go and charge, and then other bots turn up from elsewhere, and you get that effect where they'll come in a trickle basically, and it gets really annoying, particularly with something like a chest and a very large number of items where you might be deconstructing that chest and it'll basically take ages. The situation is similar for construction robots, and that can be especially apparent when using one's portable Roboport. Say the player wants to remove a bunch of trees in the factory. A single personal Roboport can only have 25 construction bots, so that's up to 25 trees that can be deconstructed using the player's personal robots. All remaining trees will be assigned to robots from the main logistics network, and the player will have to wait for them to arrive for the trees to be gone, even though the player's personal robots are right there with nothing better to do. Again, lazy bots. So basically, if you play the game, particularly the later stages of the game, and you'll have encountered this situation where you're right in the midst, you've got bots yourself, you ask it to deconstruct a load of stuff, and then it's other bots from the rest of the factory that come in and do most of the work, even though your personal robots are then idle. And it's because it's doing it on a full list basis, so it's basically going through all the list and say, right, where's my next idle bot, assign it to do, and they just pull them in from further and further away. The ways of working around this is you do all the delete, that you then undo it once your personal bots have done it, you then redo it, you then undo it, you then redo it, you undo it, or you can go and sort of deconstruct your personal robot, the wider Roboport network, and basically that's how I tend to get around it. But it's just a real faff and a typical thing that for a quality of life feature improvement. The new way, choosing a robot for a task from only the first idle robot clearly isn't the best strategy. Assigning a task to a robot that is currently busy but nearby may be a better choice, even if the new task may have to wait until the robot finishes its other tasks. This required two main changes to the logistic network code. The first change was to allow a robot to have multiple tasks assigned to them. Much of the code has been written with the assumption that a robot has exactly one job, but after some code refactor, robots now have a queue of tasks. So they'll basically have an array on them which has a task list, basically. Second, we need a way to select a robot for a task. Each task has a starting position. For example, a deconstruction order starts at the entity to be deconstructed. Until now, the selection process was simple, just select the idle robot closest to that point. So in this example, these bots that fly in later are the closest ones, but of course they're still further away. But now, when we can select a robot with one or more queued tasks, the process becomes a bit more complex. The new metric for robot selection is the arrival time. For an idle robot, its arrival time is simply the distance to the starting position divided by its speed. For a busy robot, we can look through its queue of tasks, figure out where and when the robot is going to end up when it's done, and then add to the flight time from there to the starting position of the new job. So if a robot's been given 5 jobs because it's now got a task list, it's going to move about doing those jobs. So where does it finish up, and where is it? How quickly could it get to the job that it would need to do? When selecting a robot for a task, we select the one that is going to arrive first, even if it has to take care of other things before that. It is worth pointing out that the arrival time calculation is only an estimate. For example, we simplify the effects of the recharging time. A keen-eyed player will no doubt notice situations where choosing a different robot could have been a little bit more efficient, but in the big picture it doesn't seem to be very noticeable. I guess because you could end up with thousands of bots, it averages out that, maybe if it would have been slightly better to do a different calculation, but it works because you've got a lot of bots, basically. Let's see how the new system handles our previous 2 examples. The initial batch of robots is tasked with transferring all the items, which results in them shuffling back and forth between the requester and the provider. So this is how you would always this is what happens, particularly when you're you're new to the game. This is kind of what you expect to happen. So you sort of assign them a job, or you hit this requester chest, and you sort of assume that the nearest bots are going to come in and do back and forth. And if you've got very few bots, that's what they will do. But as I say, what actually happens at the moment is this effect where they come in from all sorts of different parts of the factory. So this is obviously quicker overall, and also you're not assigning the bots that are doing the other transfers may be better off doing local transfers. So the net effect of this is going to be a lot more efficient for your entire factory, because it's going to say, right, well, it's only going to drag bots in from way far away. If it literally works out, well, there's so much needs transferring, we need lots more bots on the job. Deconstructing trees, each of the player's personal robots does more than just a single tree. Robots from the main network still come out to help, but this time they can help get the whole job done faster. So again, this is what you expect to happen when you do a big deconstruction job. Your bots go out and do so, and then keep going, basically. And it's only because you've put you've only got 25 bots here. And it's only because you've done so many orders that it's more efficient for some bots to come in and do a bit of the job. But you notice that the job ends really quickly. I mean, I don't know if I can... So you can actually sort of see that's a 15-second video. And it's an 11-second video. So it doesn't seem a lot. But obviously that depends on the trimming. But even just looking at the time of the video. And this includes all the charging. Look, so the actual job starts at 2 seconds. And is finished by 7 seconds, or 8 seconds, call it. And in this one, it starts at, well, 2 seconds, call it 1 second. You can just feel it's longer. So it would have finished by now. In the other example. Right, and it's finished now. Well, it isn't really, because you still got the, there you go, 14 seconds. So it's going from, it's double the time, basically, or half the time, basically. So yeah, really big fan of that, basically. Performance. Having a simple list of all busy robots and going through each time a new task comes in may work fine for small factories, but with several thousand robots flying everywhere, it can quickly become a UPS drain. To alleviate that, we implemented a different representation. Whenever a robot's queue of tasks is updated, it calculates its final position estimate, that is, its final position and the time at which it will finish. Each map chunk now stores a list of all busy robots that are estimated to finish on that chunk. So, when a robot updates its final position estimate, it registers itself in that chunk's list of robots. When searching for a robot for a particular task, the game now starts its search at the chunk where the robot's starting position is located and continues its search in an outward spiral. Storing busy robots on chunks and searching in a spiral improved the performance by a lot, and even factories with thousands of busy robots run well. And so an improvement that they've made is basically to localize the search. Smarter Robot Other Things by Clonan. While playing and developing the expansion for the last 2 years, we have also accumulated a few more features and changes to make the robots feel smarter and work better. Roboport robot requests. There are some situations when you need to make sure some Roboports always have robots to service tasks. For example, if you want a little resupply point with buffer chests, you want logistics robots around to quickly empty your trash and refill your supplies. It is quite annoying when all the materials are right there, but you are stuck waiting around because due to natural robot migratory patterns, the Roboports in the area are quite empty. It could be solved with requester chests, inserters, circuit networks and such, but we decided a smoother approach. You can now set logistic requests for Roboports directly inside the robot GUI. Robots will be dispatched from other Roboports to fulfill the request. Important to note, robots will not be taken from storage or provider chests. What they're saying, basically, is you can set a logistics request for the bots within a Roboport. So you can basically tell it, right, I want to always have, as it's showing here, 100 logistics robots available in this chest. It's interesting that it has a big old list like this. I don't know if that means certain things, because there's only 3 things that can go in a Roboport, which are logistics robots, construction robots, and repair packs. Those are the only 3 things that can physically go in a Roboport. So why have we got a big long list here? It could just be because that's how they've done it, and a hint of what might be a reason for that you can set bigger lists. And it sounds like these are fulfilled by robots moving to the Roboport. Robots will not be taken from storage or provider chests, so it won't go and pick up a robot from a chest and put it in the actual Roboport. It just means that bots will fly to that Roboport and wait there. I'm assuming that it's more like a buffer system, because if it did that, it wouldn't solve a problem. Because if you think about it, if it was to work like a requester chest, then 100 bots would sit there and never leave. You would always have 100 bots in that chest, because in a requester chest, only like inserters can take stuff out of them. The bots will never take stuff out of a requester chest. With this new feature, we can set all the Roboports near our resupply point to always have 100 logistic robots available. Once we arrive, our needs are serviced in record time, and afterwards you can see robots arriving to get the Roboport back up to 100. Another nice use of this is that we can use the Roboport requests to remove certain robots from the network. Perchance we had some mod with higher quality worker robots, we can request the low quality ones and remove them with a filter inserter, over time removing the worst robots from circulation. Now, this I'm wondering is this a we're getting better robots in Space Age. There are obviously mods that have better robots. But yeah, this to me implies that we're getting level 2 and maybe level 3 robots, meaning actually improved, better robots. You could also imagine you have like distracted robots and all these sorts of things. My hope, I think this is a bit far-fetched, but my hope is that you've got more automated ways of using military robots, because they're just completely pointless at the moment. So I don't know if that is going that far, but it would also then explain, at the very least, say we get 3 levels of robots. So we get level 1, 2 and 3 construction robots, level 1, 2 and 3 logistics robots. Maybe we'll get advanced repair packs, but that at the very least is then 7 things that you might want to request in the chest here. So yeah, so that explains maybe why this is a bigger list, that we're getting extra robots. You could imagine dual purpose robots as well, where they do both logistics and construction, multi-purpose robots. Maybe space robots as well. There's some special version of a space robot. Better robot charging heuristics. When a worker robot runs low on energy, they need to find a nearby robot to charge at, but they need to be a little bit smart about it. For instance, if they always choose the closest Roboport, then you would get queues and traffic jams at some Roboports while others are completely empty. For these smarts, we use quite a simple heuristic, factoring in not just how close the Roboport is, but also how many robots are currently charging there. Typically, this worked well enough, but every so often you could encounter a little inconvenient situation where they are still bunching up on some Roboports while ignoring others that are just a little bit further away. And this is the classic example. You put a load of Roboports in, and they basically all try and charge at the first, 3 or 4. A couple finally get to the end, but these guys are just sat here waiting when you've got empty charging slots at the end. In some extreme cases, this can actually be quite a problem, as the robots waiting to charge still use energy for hovering, so lose more energy in a positive feedback loop where all robots who join the queue will fall to 0 energy while they are waiting their turn. Generally, though, the main problem here is that the player looks at the robot and thinks, these robots are so dumb. Not the end of the world, but we can do better. Surprisingly, in this case, the issue can be helped a lot by just a small improvement in the heuristic logic. When deciding which Roboport to charge at, the robots crucially did not consider the current robots on the way to their Roboport, only those already in the queue, and did not factor in how many free charging spots the Roboport has open. By adding these 2 extra parameters into the equations, the distribution of Roboports improves quite nicely. So what that's saying is basically, you see this sort of queue waiting here and here. I mean, those are actually waiting for this one and these ones are waiting for this one. That's all they're looking at. So the fact that there's loads of bots coming in, those aren't technically, I guess, in the queue. They only must get added to the list that is the queue once they've arrived and start waiting. Now this next one, this next one is like something if you've ever built a big factory and it's gone round a lake, or in particular, if you've got a Roboport network that goes right around a lake. So if you imagine there's a lake in the middle of this diagram, that's how you need to think about it. Mitigation for robot pathing over lakes. It has been a problem for a long time. The robots are pretty dumb when it comes to pathfinding and try to fly over areas that have no logistic network coverage. This is because for performance reasons we don't do any pathfinding at all. The robots just fly in a straight line to the job position. One major problem with this is the possibility of the robots getting stuck in an infinite loop. This is because they fly over an uncovered territory, a lake typically, run out of battery and return back to recharge and try again. Obviously, they will never make it. There are some slight exceptions to that. If you buff the speed of the robots, then they might, you see in this example, they're not, if that's halfway, they might get enough speed boost that they would get halfway, and then they would make the decision basically to say, right, well, this is my closest Roboport, I will fly across. But the speed buff gets very expensive very quickly. This issue was notable enough and annoying enough for us that we really did want to come up with a fix. The solution we came to was a smart trick in the Roboport selection when they run out of energy. Usually the robot just chooses one of the nearest Roboports, which is fine for normal circumstances, but in this case leads to the robot turning completely around in failure. As I say, it gets there, says, getting to that point, isn't it? And saying, right, where's my nearest Roboport? I need to charge, and it happens to be directly back again. So they just go back and forth and never make it. So we changed the selection logic so that the robots try to always charge at a Roboport that is closer to the destination than the robot is. This means that even if the robot will potentially fly with lower energy for longer, it will always be able to make some progress towards the target and eventually complete their mission. This is saying these bots get to this same point where they run out of charge, right? And instead of saying, right, where's my nearest Roboport, they say instead, the Roboport they want to charge at has to be closer to the destination than the robot is. So these are saying, right, where is a Roboport that is closer to the destination than me? Go charge at that, go head towards that Roboport. I think they're saying, like, with this not perfect thing, that this is, you still get this behavior where they're going all the way up here to charge. So they're going a huge distance, but of course, eventually they will make it. It's not a perfect solution, but should hopefully help prevent the most egregious issues of this technical constraint. As always, let us know what you think in the usual places. I say this one with the big long list of things, and the hint maybe that we're getting level 2 robots is also really great, because one of the big limitations on megabases is basically the bots and things like that, because even though you can do the bot speed, they're never quick enough, and they're having to travel such huge distances that you can't just usually cover your entire base in a logistics network and expect it to work. You kind of end up having to do like constrained logistics networks. One of the things they did mention is making it easier to do bigger bases would allow you to build lots of rockets and send them up to space platforms, and because the way they're talking about it, you're going to need a bigger base. One of the things I would say that is interesting about this is that they're not releasing these changes yet. So all of these changes sound like they're coming in this, with Space Age. I know they've said that they're free, basically. The reason, I think, is probably because it's like Factorio version 2.0 is effectively a new engine. It's like a proper full engine upgrade. Because if you think about it, why couldn't this just be added in now? It's a quality of life improvement. They said they're going to do it for everybody when it's done, so why not just introduce it now? To me, it suggests that they've kind of refactored the code enough that it's basically a new engine. They couldn't just sneak these features in because they've completely reworked it all. I was also hoping that I thought this might have a little Easter egg or something, or like a little hint as to something that is coming as a new feature. But I can't see anything. We've just got Circ. It's a weird list of stuff. I don't know who would have an actual thing like this, because it's got wooden power poles, loads of regular power poles, and all sorts of stuff it wouldn't normally carry. I think there's quite a lot of these coming, is my impression. I'm really happy with this type of thing, because a lot of like this one in particular, the deconstructing trees was always such a pain in the bum. If you have been watching, I hope you enjoyed it, and if you've got any comments or thoughts, then please leave them in the comments section. I'll be back next week to read through the next Friday Facts. If you want to join me and speculate along, then you can find me on Trismegistus on Twitch. Thanks for watching. Cheers. You're going to need a bigger base.